Welcome to another of our webinars. Today's topic will be taught by the engineer Eric Alcantar, who is the automation and control engineer of Sumitomo Group. So, Eric, the time is yours.
Thank you, Iram. Hi, everyone. My name is Eric Alcantar, as Iram kindly introduced me to you. And well, yes, today I want to share with you some key points that hopefully will be useful to you when choosing a variable frequency drive for any of your applications. Of course, we will be talking about Invertek, that this is a brand that is part of the Sumitomo Drive Technologies family. And I will talk to you about it a little bit later. So let's start with this session. Well, my name is Eric Alcanta. I'm the automation engineer for Sumitomo. I'm based in Mexico. This is my email for you if you have any further questions after this session that maybe did not rose up during the session. You can write me. I will try to answer you as fast as I can. So this is my contact for you. And this webinar is thought to be as clear and as short, but resourceful for you. So if something is not clear, maybe my English is not so good. So I will ask you for a little bit of your patience. But anyway, you can write any of your questions in the question box, and we will answer them at the end of the session. So I will talk to you about Invertek. What is Invertek? Invertek is a brand, a manufacturer, a drive manufacturer. The factory is in the city of Welshpool in the UK, and the presence, Invertek has presence in over 80 countries around the world, mostly around Europe and also in Asia. And now that Invertek is part of Sumitomo Drive Technologies, of course we are bringing this technology to the continent, to our continent, to the Americas. So of course, I am responsible for this, supporting this brand right now, and I will show you this slide, and I will show you how to choose and what are the key factors when you that you need to have into account when selecting a drive. And well, there are several factors. The most important we consider are these factors, starting for the supply voltage available for your drive. Of course, the motor power that will be required for the drive, and also the maximum motor current. I will talk to you about this a little bit further. Of course, the application will impact directly into the motor current demand, the environment, and the field bus protocol, if you have any in your application. So I think these are the most important key factors. Of course, there can be more, but we think these are at least the most important at the beginning when selecting a drive. So what are most of the people is used to say, okay, I have a, for example, 25 HP motor, so I need to select a 25 HP drive for this motor. And then most of the people, they say, okay, this is good, this is enough, and they tend to select like this. Of course, this is technically this is correct, but it is not complete. We need to take into account the other factors that I mentioned before, and because if we do not take them into account, maybe this can be a problem in the future, and sometimes because of this, it's required the drive is required to be changed to another part number. So what would be the process that you must follow in order to choose a proper drive? So first of all, you need to at least this is the fundamental part of the sizing. You need the rating plate of the motor. For example, I have here a picture of a marathon motor, and as you can see, the first thing that comes up is the voltage and the current, the amps required by this motor at a certain level of voltage. For example, here, this motor demands 120 amps at 230 volts, and basically half of it at 460 volts. So 60 amperes for at 460 volts. So this will be the main information that you will need. Of course, there's another point that you may need. I will show you why, but you will always ask for the ratings plate of the motor. This is fundamental to size a proper drive. So I will start point by point. So well, voltage and current. You need to know what level of voltage is going to be used to supply the drive. Of course, it depends on the region that you are based on, but mostly these are the most common voltages around the world: 200 to 240 volts, 380 to 480, or maybe for bigger power motors, 500 to 600 volts. So also you have to know if this supply voltage will be in three-phase or single-phase, of course. So this will determine the part number that you will use for your drive. Of course, this impacts directly on the power that your drive will be able to supply to your motor, and this is the basics. But sometimes we don't get the rating plates maybe from our customer, or we don't have let's say the complete data of the motor. So if this happens, you can always calculate the current out of the voltage that you will have. This is basic. This will be the main factor that you will take into account for the power of the drive. So you will need the current, and if you don't have the ratings plate, you can calculate with this formula. I am showing you the formulas for a single three-phase and also two phases, but anyway, the most common is three-phase or single phase. And for example, I have here the calculation of the current for the motor, the marathon motor that I just showed you. And as you can see, well, I'm sorry I didn't translate the results, but I think with the formula you can understand. This is the current. And as you can see, I'm using here the three-phase at 230 volts, and the result is 120 amps. And if I go back to the motor's plate, you can see it matches here the 230 volts. 120 amps at 230 volts. And basically, the calculation is very similar to the real current of the ratings plate. Of course, here in this formula, you will need the efficiency of the motor and the power factor. Here, I'm going to point at the slide. Power factor and the efficiency. So this will also be in the motor's plate. It's not very clear, but for example, here behind the 120 amps, there is efficiency, 94.5%. And the power factor is also known as this cause fee. Sorry, I don't know how to say it in English. But when you see this cause and fee, this is the power factor. So sometimes you don't have this data. So what you can do is to take, let's say, a mean or a standardized value. For example, for the efficiency, you can use 0.9 or 90%. And for the power factor, you can use 80%, as you can see here. And this will be, of course, not the exact value, but it will be really close to real motor data. So this is very important. The current, you will see why the current is very important. I will explain you in a minute, but the current is very important. Then the application. This is where the current plays a key role in the size of the drive. Larger current, you can have larger current demand in the process. For example, in some moments the process may be mechanical torque during some periods of the process. This will be requiring more current of your motor, and the loads will increase for the drive. And also depends on the application. It may use a little bit more current, or maybe a lot more current at the start of the process, when starting from 0 to the speed that you need. So this will impact directly in the current demanded by the motor, and this is known also as the overload. Maybe you you have heard of it before. And there are some overload standards in mostly all of the drive manufacturers. For Invertek of the drives, this will be, for example, for the E3 family. This will be, you can select the application for the E3. There's a macro configuration that you can use to say, okay, drive, you will be using your power for an industrial application. So the drive will give you 150% of overload, but you can also convert it from industrial to pump mode or also to fan mode. This is a macro configuration. This is the parameter 13, and so the inverter will adapt to the overcurrent, to the overload needed for your application. This overload means 50% more of the nominal current provided by the drive. So 150 is 50% more current, 10% more current, or 10% more current for pump and fan modes. This is the overload, and in example here, if, for example, my drive, in the case, going back to the motor that we will showing you before, the 120 amps motor, maybe if it is used for a conveyor, you will use it in an industrial mode. I mean, the drive will be used in industrial mode. So it means that if the drive, the nominal current for the drive is 120, if I take into account the 150% overload, you will multiply the nominal current times the overload. This will be 1.5. And the result is that this drive will supply my motor maximum with 180 amps. This is, of course, in a short period of time. Sometimes it depends on the drive, but the Invertek drives can support this kind of overload for 60 seconds. And actually, it can give you 200% of the current, or of the nominal current for 5 seconds. So this will be very important when you select the drive, and you will need to know the overload percentage for your specific application. So the current, as you can see, is very important. But also you need to take into account environment. What happens if in my site where I will install my drive, there is water splashing, or maybe there's a lot of dust particles or another material that is suspended on the air. Also, I need to know if how much space I have available for this for the drive. If it is a corrosive environment, for example, if it is near to basically in the coast, for example, there's a lot of salt in the air, so this can be corrosive for some kind of electronics. And also the altitude. The altitude has a great impact on the drives. And I will show you some examples. talking about suspended particles, maybe you will need a specific IP level of protection. For example, here in this example, we have two variants of Invertek drives. This one is IP66 rated protection. So this is completely sealed. It's protected among water and also dust, as you can see here. And you can mount it directly in your process outside of a control cabinet. And also we have another variant, which is the IP55 drive, that maybe it is not completely sealed for dust and water, but it has fairly good protection against environment conditions. So you can install it outside a control cabinet. And this leads me to another important factor for my drive, and this is the space. The space available for the drives. This can be very helpful. For example, if my drive has IP66 level of protection or IP55, because I won't need an extra control cabinet for my drive. For example, if I scale up my application, if I add more drives than the ones that were used at the beginning, so I can save. Basically, I can save money with this because I don't need another extra control cabinet. And for example, sometimes you have like, for example, this machine that is kind of an agitator. Sometimes this will require a drive, and for this I will use here a control cabinet. This is the usual installation for this kind of machinery. But what happens if I can get rid of the control cabinet and I put directly my drive outside a control cabinet? If I mount it directly in a way that I can only use for example, the selector and the buttons in the keypad to run my machine. For example, this will save me some money. So this is possible. And of course, I want to point here that all the drives in all the Invertek drives have a variant with a certain IP level of protection. Some of them are outdoor rated, so they have also a NEMA 4X certification, so they are protected against corrosion also, so you can install them in outdoors. And of course, you will only need to protect them from the sun, but well, this will be very usual in any brand. Also, the P2 family of Invertek drives are certified by the Dmv certification. This is the global marine certification. So this is suitable for installations, for example, in ships or in the coast. It's protected. It has a specific or a special coating in the PCBs, so they are protected against moisture and dust. So another of the factors is altitude. How does altitude affect the drive performance? This is basically a cooling that is reduced. The cooling capacity is reduced as the altitude is higher, because the more high is altitude, less the more less is the more dense. Sorry, is air. So in these particular cases, the drive must be oversized. And why? Of course, this is not only for Invertek drive. This applies for any electronics in the market, because layer is less dense. You will need to oversize the current for your electronics. All the drives, including Invertek, as you can see here, in their user manuals, they include these kind of tables where they specify the percentage of the rate or the percentage that is rated for the drive as the altitude is higher than a certain level. For example, here Invertek tells you that over over 1,000 meters above the sea level, every 100 meters after this 1,000 meters above the sea level, you will need to rate 1% of the current that will be provided by your drive. So, for example, if your drive was rated with a nominal current of 72 amps, but your altitude is 200 meters, this is 2,000 meters, sorry. So this is 1,000 above the sea level. You will need to derate 10%, as you can see here. So this drive will not provide you 72 amps. It will provide you only 64.8 amps. So if you don't take this into account, it may occur that the drive is not able to start the motor, or maybe it will be going to overload failure, for example. So this is very important, and I want also to point here, as you can see, always we go back to the current. The current is basically the center factor that you will need to take into account when sizing the power of your drive. Not the horsepower, but the current. And also there can be another factor, for example, the field bus protocol used. Maybe some factories or some systems need to be integrated with some of the field bus protocols available in the market. There are a lot of protocols, but what you can do with a field bus, basically, you can control remotely all your drives, and also you can simplify the wiring for all your drives. Instead of having lots of wires for starting, for stopping, for the speed reference, and all kind of wiring that you will need, you can use like this. For example, this is a kind of a centralized control topology, where if you have a DCS or maybe an SCADA, you can control all of your drives, over a fieldless protocol. This can be deterministic for which drive you will need. Not all the drives are compatible with all the fieldless protocols in the market. And maybe if, for example, you were going to select a very basic or very simple and cheap drive like this, like the Optus Drive E3, that this can solve as much as 85 or 90% of your applications. Maybe if you will need a specific fieldless protocol, maybe you need to scale up maybe to a P2 Optidrive. By the way, I will talk to you about the families in Invertek. So don't worry if you don't understand what E3 and what P2 are. So the fieldless I was talking about. For example, some drives are compatible with Ethernet IP, but some other drives will be compatible with Profinet, for example, or Ethercat, or maybe another kind of application. For example, in intelligent buildings, you will need VACnet, for example, is a very wide use fieldless protocol for intelligent buildings. So not all the drives will be compatible with all the fieldless protocols in the market. As you can see here, as well as E3 and P2, they are both compatible with Modbus and CANopen. I will talk to you about this a little bit later. But for example, in E3, you will only have available Ethernet IP. It's not here, but there's also another module that is a Profibus DP module. But the Optidrive P2 is compatible with another fieldless protocols, such as Modbus TCP, Profinet, Ethernet, as well as devices, for example, for old Allen Barkley control systems. So this would be the key points that we wanted to share with you. Now I will go more into detail about Invertek drives and the families. This is very simple for you. We only have basically two families, two drive families. One is the E3 family, the Optidrive E3. This is, as I told you before, this is a general purpose drive that we have available. It comes in the IP protection levels in IP20 and IP66. In IP20 is up to 50 HP, and in IP66 is up to 30 HP. This is a very robust, drive. It can solve basically most of your applications. It has another feature that I will describe a little bit later, but we have this E3, and also we have the P2 family. This is the other family that we have available. This comes in a more wide range of powers, from 1 HP to 358 HP. There are also another variant here for the IP level of protection. We have available the IP55, and as you could see in some slides before, here, these are the IP55. And this is the high performance and advanced control drive. This has some other key features that can enable your applications for more advanced control. I will go into detail in a minute. I have here an example, a very quick example, because I want to show you another tool that we have for you in order to make you easier to choose a drive from Invertek. For example, if we need to select a drive for an 50 HP motor supplied at 440 volts. This is very common over here in my region. And if it's going to be used in a conveyor belt, this will be an industrial application. Also, the application tells me that it has to be compatible with Profinet protocol. And also, inside there's a lot of dust. So what will be doing here? As you can see, we don't have the motor plate. So I will do this example with the calculation that we saw before. So for this, of course, I have already solved this. So if my motor power is 50 HP and our supply voltage is 440 volts, three-phase, I'm using here an efficiency factor of 90% and a power factor of 80%, just to be quite a standard. And sorry, this will give me 68 basically, 68 amps. But my application is a conveyor belt, so my application is an industrial application. I will need a 150% overload for this. So I will apply this 1.5 factor to my nominal current, and I will need at least 101 amperes, 102 that need to be supplied for my with my drive. So this is the fact. This is the key factor that I need to take into account. So I want to show you here, before talking about the families, before going into more detail, I want to show you this tool that we have available for you. You can go to the Invertek Drives webpage, and we have a drive configurator. This is very useful. Actually, we use this quite a lot ourselves to offer, because of course there's a lot of variants, there's a lot of part numbers. It's not easy to memorize all of the part numbers. So you will find the drive configurator over here in the variable frequency drive section. We'll see here the two families that I showed you before, E2 and E3. It depends on the application, as I told you. For example, I will start with the Optidrive E3 because, as I told you before, this is a general purpose. This will solve many of the applications. So I will start here. And when you are in this page, you go to Drive Configurator tab here, and this will show you all of the variants, all of the part numbers available. Of course, there's a lot, so you can use the filters in this configurator to select the proper drive for your application. I will go back into my slides, and I will see here that I will need a maximum current of 102 amperes. So what I can do here is to use HP or the kilowatts. This is the power, but we can use also the amps to select the drive. So as you can see here, there's a message here. As you can see, the drive has to be equal or higher than the motor rated current, as I told you before. So first, I will put here the supply voltage that I have available. As I told you before, I have 440 volts supply voltage. Then here I can select the motor current. I know that it is 67, 68 amperes. So either I can take this maybe, and as you can see here, it's putting me directly. This is the part number. It's a 40 HP drive, and it is a 61 amps drive. Of course, I know that this is not the maximum current that this drive can give me. You can multiply this, and you can see. Okay, let me show you. I will take my calculator out here, and you can say, okay, 61 times 1.5, this will be 150% overload. And I can see here that this drive can give me up to 91 amps. And as you can see, maybe this is not enough for this drive. And I want to show you here. Here, as you can see, actually this is the example I am using. 60 amps, and it's telling me 50 HP. So I will go back, and I can see, of course, this is not enough. So I can go back. I'm repeating this again, and I can take 72 amps. And yes, I can see here, this is 50 HP. So this is the part number. And if I do the math here, I can see, okay, this can give me 72 times 1.5, 108 amps. As you can see here, this would be the best drive for my application. But what happens? My application also told me that it has to be IP20. So maybe this is not the correct part number. And also it told me that it needed Profinet. So as you can see, maybe if this could be, let's say, partially correct answer, the answer is not complete. this is not the part number, because I need to take into account the other factors. So this will not suit my application. So I will be looking maybe into another family, let's say Optus Drive P2, and we will repeat the process. Here I will take, for example, the 72 amps, and I can select here IP55, and also the voltage. And as you can see here, we have several options over here. It's basically the same. The only thing different is that this is using a kilowatt power rating, but as long as the amps are covered, you will know that this will be useful for the application. So I wanted to show you this tool. With this, you can go here and select the part number by yourself. Okay, now I will go into detail for the Invertek Drive families. I will try to be short. We don't have a lot of time. So I hope this was useful for you. I will start with the E3 Optidrive family. As I told you before, this is a general purpose drive. Sorry. I don't know what happened with my PowerPoint. It closed suddenly. Sorry. Okay, here we go again. So this is the Optus Drive E3. This comes in powers from half HP to 50 HP. This can be powered from a single phase or three phase input. This also, we have a variant that can be supplied with more domestic voltage level, such as 110 or 120 volts. I don't know if this is usual in your region. This is quite usual over here in my region for domestic electric installation. So this is the Optus Drive E3. What are the key features of these drives? Well, one of the key features is that you can use these drives to control 4 types of motors. The most common are induction motors, but you can also control brushless DC motors, permanent magnet motors. This is open loop without an encoder, and you can also control synchronous reluctance motors. This for motors with any of the Opti drives from Invertek. This is also for the P2 family, which I will talk to you about a bit later. We have, as I told you before, the IP20 level of protection drive, but we have also the washdown ready version of it, which is IP66 and then NEMA 4X certified. We have a variant. This is a switched variant of the drive. It has its main interrupter over here. It has a pot for the speed reference, and it has this selector. But we have another version that is non-switched, and it only comes with the embedded keypad. as you can see here. I will jump this. This is the same I told you before. One of the key features of the Optidrive E3 drives is the connectivity. You can have in this RJ45 port, you have two protocols. You have Modbus RTU and you have CAN-open. Both protocols are embedded, factory ready. And also there's a accessory. It is the Optus Smart that enables Bluetooth connection with your drive through an application. I will show you in another slide a little bit later. But this is also very, very useful. This is a very practical tool, and it has some advantages. Also, for the installation, you have two options. You can mount it in a rail, in a DIN rail, a standard DIN rail, but of course you can mount it directly on the control cabinet plate with screws, basically as any inverter in the market. But you have both options with the Optidrive E3, also with the P2 drive. Well, this is part of the features of the IP66. For the E3 Optidrive, we have an Ethernet IP separate module. It's basically a converter that converts the embedded protocols to an Ethernet IP. There's another module, as I told you before, which is a Profibus DP module. It has a macro that you can convert this drive. It's very flexible. You can convert it from an industrial mode, which is 150% overload, as I told you before. You can convert it from there to a pump mode or a fan mode. This has a pre-configured characteristics. For example, the fan mode has a spin start, so it will detect if the fan is already spinning because of air flow, maybe that is existing. It will detect the direction of the spinning, and it will try to synchronize with the speed and with that direction. And for the pump mode, also for the fan mode, the torque curve is adapted to a variable torque curve for the drive. For the industrial mode, it uses a linear torque curve, constant torque curve, sorry. These are the modes that I was describing. Of course, for example, I want to point over here for the fan mode and for the pump mode, we have an internal PI controller. So you can use an external, for example, a pressure sensor or a temperature sensor to control automatically your drive. It has a fire mode. In some other brands, the fire mode is only available for the high-end, for the high-end families. You can have it here in Invertek, since from the most basic drive, which is the E3. And also I want to show you over here. Of course, you can have EMC filter. It is already integrated, but you can use an external EMC filter, and also an brake resistor. There is some models, not for all the applications, but the sizes 2 and 3 of Invertek drives has this accessory that it is inserted directly on the drive frame, which is very useful. You don't need an extra space for your control cabinet. For example, this is an example of the PI control for a pump to control to have a constant flow. If you have a pressure transducer, for example. As I told you before, the Modbus RTU and the CAN open connectivity. And these are another accessories. We have the OptiStick, the OptiPad, which is a remote display that you can use to install it in the front of the control cabinet outside, so you can control it from outside. This is also very interesting because you don't need different models for the different part numbers of the Invertek drives. The same model applies for all the Invertek drives available. So this is very useful. This simplifies basically your stock. You can use the same. There's also a cable splitter. This is used for mainly for communications, for fieldless protocols, and some other expandable I/O models that you can use. Also, we have an input and output chokes in case you need maybe for a high harmonics installation. You can protect your drive from the mains grid, and also you can protect the grid from your drive. And also there is another PC interface. You can connect your PC through this converter. And of course, this is something I wanted to show you. There's a software. You can install this on Windows. It's free to use. It's very important for you to know. This is free to use. You can download it for free at the Invertek webpage. I don't have the slide here, but there's also mobile applications for the OptiTools and for the Bluetooth connection with the Invertek drives. The tool is also called OptiTools. It's also available for the Google Marketplace and for iOS phones, for iPhones, basically. So you can also download for free. And this application, you can use it to set the parameters of the drive, to save it to files, and you can also monitor and control your drives. This is using Bluetooth connection or maybe a direct connection with the cable I just showed you before. For example, the OptiTools Studio for Windows also it has this scope function that you can use to log data and to trace it real time. Also, the parameters can be set real time. This is quite useful for the commissioning of the machine or of your drives. Okay, this is the end for the E3. I will go quickly to the P2 presentation. Some of the features are in common with the E3 family, but for example, this opens the range of power available for the drives. this comes up to 350 HP power. And these drives have not a 110 volts installation, but they will also be available for single and three-phase input. The IP55 drives are only available for this family, for the P2 drives, and as I told you before, this is the high performance drive. As you can see here, there are some really common features. For example, the thin rail mount available, as well as the screw mount. The Modbus and can open embedded in the RJ45 port as a standard. But the difference is that you can expand to another fieldbus protocols with this kind of removable modules or modular models. This would be redundant, but you can insert these models directly into the P2 drive. Also, I want to point out that the P2 drives come with a Tft display, so it is a multi-language display, text display, high resolution, and you can display some customized warnings, customized messages. It is a more clear and easy to use drive because of the display, that it can also make a difference in some for some users. As I told you before, the IP55 available, the IP66 are the same as the E3. As you can see here, I have in this picture the switched version and the non-switched version of the IP66. It's well to know that the IP66 has two RJ45 ports instead of one. And this drive can, of course, for example, here you can use it's an universal drive. You can use it for induction motors, for permanent magnet, synchronous reluctance, and brushless DC motors. And this is the same as the A3, but with the difference that the P2, in the P2 there is a module, external module that you can insert, and this is an encoder module, so you can use the permanent magnet motors also with closed loop control. The A3 drives are only available for open loop control. So this can be particularly useful in more accurate, more precise applications that maybe you will need a more fine torque control. Actually, one of the features of this family is that you have a third generation vector control method. You can have speed vector control, but also torque vector control instead of only speed. The torque vector control can be open loop or closed loop with encoder feedback, as I told you before. Also, it can be used for AC induction motors, this closed loop control method. This is done by the external module. Of course, there's a more wide variants available for this P2. We have, for example, the analog or digital input card, or the relay card, and also the protocol cards I will show you over here. For the P2 drive, we have Profibus, we have Profinet, DeviceNet, and also Ethercat and Ethernet IP available with the external modules. I will go a little bit more quick. This is very, very interesting. This P2 drive also come with a simple PLC integrated. So basically you have a PLC inside of your drive, so you can program a wide variety of logic that you can imagine. It is only limited with the quantity of input and output available, but basically you can do as many applications as you can imagine with the PLC, as you know. It also comes with a dedicated hoist mode. This is used for hoist and cranes. It has a safety input, dedicated safety input for STO. I don't know if you have heard of it. It is a safety standard. Also, you can use it as a master in a network application, in a fieldbus network. This is not available in the E3. If you want to use your drive as a master in a communication system, you will need to use a P2 drive. So you can use, for example, a P2 as a master and E3 as a slave, or you can use only P2, for example, as a slave also. You have also a PID, a full PID, instead of the only the PI only available in the E3 drives. This can be used for speed control in the vector speed vector control, or for torque control, for example, in winding machines, as you can see here in the picture. This is the 3GV vector control, as I told you before, the third generation vector control. You can use it also, as you can see, for cranes or for hoists. And this was I wanted to come this point. The Optitools has also the PLC functionality for the P2 only, and you can program in function block diagram language. This is the only language available right now. But also the Optitools Studio can be used as a PLC IDE program, as you can see here. We have the Optitools Mobile, as I told you before. It is available for the App Store and for Google Play Marketplace. It comes in English with these languages. Maybe for you it's interesting only in English, but this is free of charge. You can use it to control, to parameterize, and also to monitor your drive. This is quite useful for commissioning, as I told you before. Sometimes the control cabinet is far from my motor, or maybe the mechanism that I want to analyze, and I want to watch how it's working. And you can use your cell phone to start, to stop, to jog maybe the motors, and this can be really, really useful in commissioning. The simple PLC, as I told you, basically you can do whatever you want. If you have PLC experience, you will know that it's only limited by your logic and by the inputs and outputs that you have available. This is the remote keypad I told you before. The same used for the E3. So this is very, very useful. You don't need to buy different part numbers. You can use the same for both families. And the OptiStick. I want to point out here also the OptiStick can be used to, it's not only to use it with the OptiTools and to control and parameterize, it can also be used to store a backup of your drive. So for example, if you have a large number of drives in your application, you can do the configuration in one of them, store it in your OptiStick, and then you can copy and paste all over your drives. So this can save a lot of your time. Also, it can be useful if, for example, if your customer or I don't know, if you are an OEM and you send machines remote from your region or from your city, maybe in the site that your machine is installed, maybe if there is no technical personnel, and maybe they don't want to touch your inverters, and or maybe you don't want them to touch your drives. You can send them your OptiStick with the ready to run parameters, and they only tell them to copy and paste, or maybe just paste the parameters, and you can save some money because maybe you don't have to travel to that site. I don't know. There's a lot of possibilities with the OptiStick. It has also an NFC communication. To be honest, this is not common, but maybe for some of you can be useful. But well, yes, this is the OptiStick. And to end the presentation, we have also a USB PC connection kit. This is used to connect directly your PC to the Drive network. As you can see here, and I forgot to tell you, you don't need more than one of these accessories to connect to all your drives. For example, if you have a network connected through splitters, as you can see here, you will need only one PC connection cable, but also if you have the OptiStick, you will not, need only one OptiStick Smart for communicate to all the drives in your network. You only need one of them. I hope this is clear for you. I will recommend you to use the OptiStick Smart because almost all of the pieces all in the market already come with Bluetooth connection, and this is enough to make the configuration, the parameters, the monitoring. But of course, if you want a safer, or let's say, if you are used to make direct connection to your drives with a cable, this will be the accessory that you can use. And this is the accessories I told you before. There's also a RJ45 hub, multi-port to connect several drives. And yeah, but basically that's it. I will close this. I will close this also. Sorry, here I lost my presentation. Yeah. Now we will answer your questions. If you have any questions, please write them in the chat box. Sorry, in the question box.
Thank you very much, Eric, for this to give this topic. And well, only for remember, you can find the question box in your GoToWebinar panel that shows in your screens. You can write over there your questions. As well, if you are in a mobile device, you can find this option of question or chat. It will give some minutes only for you can write your questions. Also, oh well, here are some questions, Eric.
Yes, someone is asking if there is a copy of the presentation available. Of course, we can share with you this presentation. I don't see the problem.
There is another question, Eric. How could be the selection of DC 90 and 180 volts full load from the beginning?
Of DC, okay. Well, I do not understand if that DC current is for the drive or for the motor. Usually the DC current is at 325 voltage level or 525 voltage level. This is more usual. I don't know if this is correct, the 90 and 180.
Okay, thank you. I don't know if another or of our assistants have another question. Also, we invite you to visit our social media. You can find us as Sumitomo Latin America or Sumitomo Latam. You can find us in that way. Also, you can visit our website where you can find more about our products or service and also more information about the Invertek products.
Okay.
And if there is not a question, well, thank you everyone to assist to this webinar. This is all for this time. And well, thank you, Eric, for giving this interesting topic. Thank you very much. And well, see you later.
Thank
you
you
very much.